All right, I'm going to attempt to finish up chapter 6 here. Here's some answers to page 420, 6 to 18 even. You did some in class, so here's some answers to check your work. But I'm going to jump right into it. Proportional. You get problems that say proportional. We're going to write and solve the differential equation. The rate of change of Q with respect to t is inversely proportional to the square of t. So what we have to say is the rate of change of Q with respect to t is written like this, dq dt. Then inversely proportional means that the constant is up top and whatever is on the bottom, the square of t is on the bottom. So we just did the first part. We wrote the differential equation. Now we're going to solve it. To solve it, I'll move dt on that side. Okay, so I'll have dq equals k over t squared dt. Makes sense? So now I'm going to go ahead and integrate. When I take the integral of both sides, I'll do it in green here, I'm going to get big Q here. Here the k I can bring out in front. So this is really t to the negative 2. So it's going to be negative k over t. Remember, that was t to the negative 2. You take the integral. It's negative 1 times the negative 1. Put it back. So this is what I get, plus c. So that is getting from a proportion, writing and solving a differential equation. Let's see one more, perhaps. And this is one that's a little weird. It says, write the equation and solve. The rate of change of Q with respect to t. Ooh, we know how to do that. Rate of change of Q with respect to t varies jointly as x and L minus y. Well, that just means k times, that's our constant of proportionality. I didn't say that before, but k is the constant of proportionality, and it's x times L minus y. L minus y. So what I'll do here is I'll take, kind of weird, because I'll take dt, put it over here, I guess. All right, and I'll get q equals k times x times L minus y t plus c. Because remember, this is with respect to t, and there's no t here. All right? Any questions? So jointly means to multiply them. All right? When you see that in proportions. So that's one part of 6. I guess 6-2. All right, let's continue. Then there's growth and decay, which has nothing. There's no calculus going to go on here. All right, this is pre-calc algebra 2 stuff, but you might see it a little different. If y is differentiable function of t such that, remember that's such that y is greater than 0, that's what we have for some constant. Well, this translates to that. Makes sense. And that's looking very much like that logistics equation, I hope. So here's our players. There's the initial value, proportionality constant, growth and decay, depending on k. K is greater than 0, it's a growth. If it's less than 0, it's a decay. Very simple. So let's do a problem. Fruit flies. Suppose, that's my thing for suppose, fruit flies increase accordingly to the law of exponential growth. There were 100 flies on the second day, and 300 flies on the fourth day. How many flies were in the original? So we want to find out how many we started with. So here we go. We have 300 flies on the fourth day, and we have 100 flies on, 100 flies on the second day. So I'm going to divide these two equations. Let's divide both of them. So I'm going to get 3 is equal to e to the 2k. All right? Now, what that means is that I could plug 3 back into here for 2k. You see it? E to the 2k. So I'm using a little substitution. So I'm going to get 100 is equal to 3c. So I could find c, which is what I really wanted, which is about 33 or 34 flies we started with. Because there's a decimal involved, you can't have half a fly. So when you solve that, it's 33.3 repeating. So it's either 33 or 34 flies, how many we started with. So notice I took this equation and I plugged it right back in for e to the 2k. With this growth and decay, we can also, I mean, there's a problem here. Wait 1 second. I have it here. You've seen something like this. You've seen half-life. So if I told you there's a half-life of like 5,000 years, then what you would do is you would say, well, it's half-life, and some half-life. You don't see this very often, but more in physics or in anything. Half-life is 25, what did I say, 5,000 years or something like that? So C e to the 5,000, I think, I'm hoping. K 5,000 years. And if you wanted to find what K equals, now we got to do some math. We got to ln both sides. So this would be the ln of 0.5. ln this side to bring it down. And I would get equal to 5,000, I guess, K. And then divide by 5,000. If I, remember, I'm ln'ing both sides. These are undoing each other. And now I have K equal to that. So anytime you hear 5,000, I know another popular problem is if you put something in the bank and it keeps doubling. Well, if I put like $1,000 in the bank and it keeps doubling, which means I want $2,000, which I have $2,000, and that's e to the kt. Well, you can put something in for time and find out how much money that you can end up with. Remembering this is what's happening to the number, and that's the initial amount. Okay? Let's continue. Here we go. What is the general solution of this thing? Well, I'm gonna mix them up so I see x and y. I have x's on one side, y's on the other. So I'm gonna divide both sides by y. I'm gonna have 1y dy. I'm gonna move that guy on the other side. So it's going to be x over x squared minus 3, and I'm going to put the dx over there. And there we go. All right. Now let me find my paper to work it out. When I do this, when I take the integral of both sides, this becomes the ln of y equals, well, I have to find out what this guy is. I don't want to sit there and figure it too much out. I guess this guy turns out to be the ln 1/2. Because if I set u equal to x squared minus 3, du is 2x, so I got to do a 2 here, 1/2 on the outside. So it's 1/2 ln of x squared minus 3, and then we'll do plus c. Makes sense. All right, so that is the general solution of this thing. Natural logs coming through. Find the solution that satisfies this thing. Now, this is a capital T. That's a capital T. We don't have a dt. So what I'm going to do, I don't know what the heck I'm going to do. Let's see what I do here. I think what I'm going to do is move that over to the other side. So I'm going to have, if I'm right, dt 1 over t plus 45 dt equals k dt. So at this point, I am going to, this is called separation of variables. We've done a little bit of this before. So I'm going to integrate both sides here. I'm going to get kt, which is kind of cool because that's something we have. And on this side, I'm going to get the natural log of t plus 45. Then I guess there's a plus c somewhere. Okay, plus c. So if I put it all on one side of this equation, I'll get, and I'm going to use this also. So I'm going to plug in 0 and set it equal to 200. So 200 is equal to, let's move that on that side, kt minus ln of t plus 45. Okay, and now I'm going to put in 0 and 0 here. Okay, so I'm going to actually, what I think I want to do here, I'm good. I think I'm okay. Let me just double check. So, blah, 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 blah. Blah, blah. Checking my notes. Yeah, that'll go to 0. This will become ln of 45, I guess, negative ln of 45. And this will become 200, or some constant. I think that's good enough. I don't think you need to get crazier. I have never seen a problem like this on the AP exam, nor will I give you one. So it's good. And then you plug in 0 and you get negative ln, and you solve it. Negative ln of 45. But there has to be some constant, I guess. 200 plus c. Probably e both sides and go from there, but that's fine enough. Anyway, that's 6-2. There's not much to it. It's a lot of this. The main gist is separating the variables and then doing the integrals. So try something for me. On page 420, okay, 6 and 8. Well, actually, forget about this. Let's go 6 to 18 even. And then you could check your answers. Check with first slide. Because if you look at the first slide, there's the answers. Awesome. So you can check them with the first slide. Check these answers with that first slide. And we'll talk about it when you come back. This will conclude Chapter 6. Chapter 7 and 6 was like a lot of these E things and separation of variables, logistics. Chapter 7, totally different. Just to give you a little preview, Chapter 7 is graphing. All right, looking at areas. Okay, I'll see you.